Morning Calc kids, today we are looking at 3.7 implicit differentiation. Whoa, it's gonna be implicit, not explicit, because if it's explicit I couldn't put it on this website because I don't like foul language. Okay? It's a really bad joke, but I made it. Okay. Okay, let's do some reading. Let's say you get a circle of some sort, right? And this equation is denoted by having x and y both together in your equation because it's not really a function, but it's implicitly defining at certain spots. You can make it into one. Okay? So what we're basically going to need to do, and if I would read this if I were you, so just go ahead and read it. I'll read it with you. An important problem in calculus is how to find the slope when the function can't be conveniently be solved for y. Instead, y is treated as a differentiable function of x, and both sides of the equation are differentiated with respect to x using the appropriate rules for sums, products, quotient, and the chain rule. Then solve for dy dx in terms of x and y together to obtain a formula that calculates the slope at any point x, y on the graph. This process is called implicit differentiation. The phrase derives from the fact that the equation blah 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 can be broken up into three different functions because they're hidden inside of other ones, okay, without giving us an explicit formula. AKA, I'm going to show you guys how to take derivatives of beasts like this. Let's learn the rules, shall we? No, we don't. You don't have to. This is noteworthy for sure. The first thing you do is you take the derivative of both sides in terms of x. Okay, then you take your dy dx's. I'm going to use y prime a lot because remember, dy over dx equals y prime. Okay, it's just going to make my life a lot easier. So you're going to move everything with the dy dx to one side. You're going to factor it out. It's on the outside. And you're going to move this piece back over. So you're left with just your derivative of y in terms of x. Okay? Got an itchy neck. Mosquito bite in the winter. Okay, so make sure you guys write this. It's a muy importante. Let's try one. See how we got y's and x's. We got everything going on, man. So we gotta take the first step is take the derivative of both sides in terms of x. Okay. So here we go, 6y. Now we have to use our chain rule. Y is going to be our function, so we need to times that by the derivative of whatever y is. But we don't know what that is yet. So we go 6y times the derivative of the inside. The derivative of inside is whatever derivative of y is in terms of x. Plus 2y, derivative of that just goes to 2, times the derivative of my inside, which is my derivative of y, which is dy over dx. Okay? And that equals derivative of 5x is 5. And we don't have to times this one by dy over dx because that's just 1. Okay? So we don't have to. We don't have to use the chain rule. Get out of here. Get out of here, you crazy variable. You're crazy. Okay, what's our next step? Get all the dy over dx's to one side. Check. They're all on the left side, so we don't have to move any over. Okay? What next? Factor out the dy over dx. What's going on? So we take out the dy over dx. So in here we're left with 6y plus 2. Still equals 5. Check my notes, make sure. Yep. Next, solve for dy over dx. So we need to get this by itself. So we divide both sides by 6y plus 2. Those cancel. So dy over dx equals 5 over 6y plus 2. It's okay to leave y in our equation just because we're going to be given a point with an x and a y to plug into our formula to find the slope or the normal at that given point. Okay? I'm going to pause. I got to see how many parts I'm going to make this video into. Still no. Let's do another example. Suppose we had, I'm just going to make one up here on the fly, this could be bad. 3x squared plus 2xy minus, we'll go y to the third equals 81. Okay? And we want to find dy over dx. Okay? So, first thing we need, sorry about that. So, what we're going to do, first step, take the derivative of both sides. Okay? From here on out, I'm going to probably write y prime. Okay, because that's the same thing as dy over dx, and it saves me a lot of time. Okay, so derivative of 3x squared is 6x. Now, since that's in terms of x, we don't times that by the y prime, or the dy over dx. Okay, plus, roll, I'm going to hold off on that piece, minus 3y squared times the derivative of the inside, which is y prime. Okay, because that's the derivative of y in terms of x. Equals derivative of 810. For this beast, I have to make a sidebar. So we have 2xy, right? Right. In fact, we can take that 2 out in front for the time being. Okay. So we need to find the derivative of this beast. We have to use our product rule. U is going to be x, v is going to be y. Derivative of x is 1. The derivative of y is y prime. Again, we can't just quantify this in the numbers, guys. Derivative of y is the derivative of y in terms of x. It's y prime. Okay? We do our cross dealio, and we get xy prime plus y, right? Because y times 1. Okay, and the whole thing is going to be times by 2 because of that 2. So actually, it's going to be 2xy prime plus 2y. Okay, so that's my derivative of 2xy implicitly. Okay? So there goes up here. Two xy prime plus 2y. Okay. I'm going to make this into blue just because that's what we've been using for it. Now our next step is to get all the y primes on one side. Okay? So I'm going to subtract a 2xy prime. I'm going to add a 3x squared y prime to both sides. Okay, so what I end up getting is 6x, so let's cancel, plus 2y equals negative 2xy prime, right, plus 3x squared y prime. Next step is factoring out your y primes. So you pull out y prime. You have 2x plus 3x squared, right? Next, we solve for your dy over dx, dy over dx, also known as y prime. So I'm going to divide both sides by negative 2x plus 3x squared. Right? And I'm done. That's my answer. Because now this y prime's left by itself. And I get 6x plus 2y over negative 2x plus 3x squared equals my y prime. Oh, it's that easy, guys. It's that easy. Easy. Oh. Alright, well, I was going to make some executive decisions. Number one is I'm going to talk about this problem in class in probably 2 days. So I want to do this one before I set you guys loose into the world to do your implicit deeds. Okay, so this is asking to find the second derivative. Okay, so we're going to have to do the whole process, and then we're going to have to do it again. Okay, so let's get started. First step, take the derivative of both sides. Okay, in terms of x. Derivative of x squared in terms of x, it's 2x. The derivative of y squared in terms of x is 2y times the derivative of the inside, which is y prime, equals derivative of 25 is 0. Okay? Okay. Next step is you get all your y prime terms separated from your x terms, right? So I'm going to subtract a 2x from both sides. Okay? So get 2y y prime equals negative 2x. Okay? Now you solve for your y prime. So I divide both sides by 2y. Those cancel. I'm left with y prime equals 2's cancel, negative x over y. So that's my first derivative. That one's not too bad, right? You're going to be doing that one quite a lot. So we need to find the second derivative. I gotta untangle my pen. Second derivative is also known as y double prime. Yeah, I use mine just because it's less writing, and I don't want to just keep writing it. So I write y double prime. Okay. So we need to take the derivative of this beast. So we need to use the quotient rule. Because we have the top and the bottom. My u is going to be x. My u is going to be u. My u is going to be x. My v is going to be y. I'm just going to pull that negative out in front, right? Because we can. Because that's a constant. It's a coefficient. We don't have to deal with it. My derivative of x is 1. My derivative of y is y prime. Okay? So I do my cross multiplication dealio. Not cross multiplication dealio. Come on, Mr. Wilger. I do my v u prime minus u v prime all over z bottom squared. Right? If you don't have that memorized yet, guys, may I have mercy on your soul on test. Okay? So my bottom times my derivative of my top minus my top times the derivative of the bottom all over the bottom squared. Right? And that's what y double prime is. But wait! Y prime, oop, gotta put a negative sign in front of this whole thing. Right? Because the negative up here. Negative sign in front of the whole thing because there's a negative right here. Okay. Wait! Y prime is negative x over y. Y prime is negative x over y. So I can substitute that in for my y prime. So actually, this is equal to negative y minus x times negative x y all over z bottom squared. Again, because y prime is equal to negative x over y. Because you can't write a derivative in terms of other derivatives. Okay? This is no bueno. It's no good. But wait! I'm going to do something kind of tricky, guys. Bear with me. Let's negative x times negative x is going to make that an x squared over y, right? A positive. Over here, let's find a common denominator. So let's times this by y over y. So this would actually become y squared over y, right? So y squared plus x squared all over y squared. Negative sign in front of this whole piece. That y moves down with this y because they're looking for a roommate. They need someone to help pay rent. So you actually, I'm going to rewrite this too, just so it's x squared plus y squared all over y to the third, negative sign out in front. Now I'm going to just blow your minds. Just grab onto the table, guys. This will really freak you out. We get an x squared plus y squared, right? X squared plus y squared equals 25. What? So wherever I see an x squared plus y squared, I can plug in 25. So this whole mess is actually just negative 25 over y cubed. That's what your y triple prime is. Or double prime. Optimus prime. I don't know. As we'll end it, guys, I'm sure there'll be questions. Have a lovely day.